Okay, so in the previous video we were introduced to this idea of complex numbers. Remember, those are numbers written in the form a plus bi. And we looked at how to add complex numbers and subtract complex numbers, and we multiplied complex numbers. Today we're going to learn about, in this video, about how to divide by a complex number. But before we do, though, we need to understand this concept of what a conjugate is. So here we see that the conjugate of 2x minus 5 is 2x plus 5, and vice versa. So the conjugate of 2x plus 5 would be 2x minus 5. Let's look what happens when we multiply these two conjugates. Now, whether you use the FOIL method or the extended distributive property, or if you use that window method, either way, this is what we're going to end up doing. 2x times 2x and 2x times 5. Well, 2x times 2x gives me 4x squared, and 2x times 5 gives me 10x. Done with the 2x, now let's work with the negative 5 here. I take negative 5 times the 2x and negative 5 times the 5. Well, that gives me negative 10x, and negative 5 times 5 gives me negative 25. So when I go to simplify this, I'm left with 4x squared. The 10x minus 10x is 0, and I have 4x squared minus 25. So in other words, to describe what we discovered here, is when we multiply a number by its conjugate, so 2x minus 5 times 2x plus 5, what ends up happening is the middle terms disappear. Or they cancel each other out, but that's important. The middle terms are no longer there. And so essentially, if that's true, if the middle terms are no longer there, we're not worried about multiplying the 2x times the 5. Instead, all we're worried about is multiplying the first two terms, because 2x times 2x would give me 4x squared, and multiplying the last two terms, the negative 5 and the positive 5, because when I multiply those together, it gives me the negative 25. Now, the complex conjugate of a plus bi would be a minus bi. What is it? So let's look at what the complex conjugate of 4 minus 2i would be. It would be 4 plus 2i. Now let's multiply these two together. So 4 minus 2i times 4 plus 2i. Again, 4 times 4 would be 16. 4 times, let's go ahead and find the middle terms here, even though previously we just mentioned that the conjugates, when I was dealing with the x's, 2x minus 5 and 2x plus 5, the middle terms disappeared. Let's see if that happens when we're dealing with complex numbers. So let's go ahead and find the middle terms here. So 4 times 2i would be 8i. Now let's multiply the negative 2i times the 4 and the 2. So negative 2i times 4 would be a negative 8i. And negative 2i times 2i for the time being is negative 4i squared. So you can see that when we go to simplify this, 8i minus 8i is 0. So we're going to have 16 minus 4i squared. Now remember, we talked about, though, in previous videos that I squared is the same as negative 1. So to go to simplify this, it's going to be 16 minus 4 times negative 1, or negative 16, or negative 4 times negative 1 would be a plus 4. So our answer would be 20. So here, when I took 4 minus 2i times 4 plus 2i, not only did the middle terms disappear, but we're left with only a real solution. We don't have any imaginary numbers or non-real solutions left in our answer. So when we multiply a complex number by its conjugate, we are left with a real solution. I might be saying, okay, great. That's nice to see that when we multiply that, we get rid of the I, so we're left with just a regular old number. But why would I need to know that? The reason why we need to know that is, in order to divide two complex numbers, what we're going to do is we're going to multiply both numerator and denominator by the conjugate of whatever the denominator is. And really, this should say not even divide two complex numbers. If we ever divide if we're going to divide by a complex number, this is what we're going to do. So the purpose of this is we could never leave an imaginary number in the denominator. Okay, so just like you can't leave a fraction in the denominator, we can't leave a square root in the denominator, we can't leave an imaginary number in the denominator. That's not proper. So if we have an imaginary number in our denominator, we did something wrong. So we want to simplify this. And so again, the reason why we're going to multiply by the conjugate is this is going to give a real number in the denominator that you can then divide into each part of the numerator. So let's see what I mean by that. Let's look at this first example. Here we have 4 divided by 3 minus 2y. What we're going to do is we're going to multiply the top and bottom by the conjugate, which would be 3 plus 2y. So remember, when we multiply by the conjugate, all we care about is multiplying the first terms and the last terms, because the middle terms are going to cancel out. So 3 times 3 would give me 9. And negative 2i times negative 2i is negative 4i squared. Remember, I squared is the same as negative 1. So negative 4 times negative 1 is a positive 4. Add that to the 9 and we get 13. So in our denominator we have 13. In our numerator we're going to take 4 times 3, which is 12, and 4 times 2i, which is 8i. Now our answers, we want to leave these in the form a plus bi. So we're going to take, this is one giant fraction. I want to break this up into two smaller fractions. So it would be looking like this a plus bi form. So we're going to write this as 12/13 plus 8i over 13, or 8/13 times I, same thing. Because you want to look to see if that can be reduced any further, either of those pieces. 12/13 can't be reduced, 8/13 can't be reduced, so we would leave this as your final answer. So if you feel ready, why don't you try this on the next example so you can pause the video. Or if you want to watch this one as well, you can go ahead and do that. But otherwise, like I said, pause the video and then hit play when you're ready to check your answer. Okay, so for this particular problem, the conjugate of 3 plus 4i is going to be 3 minus 4i. So we're going to multiply the numerator, and the denominator by 3 minus 4i. So again, we're just multiplying the first and last terms here. So 3 times 3 would be 9. 4i times negative 4i would be negative 16i squared, which is the same as negative 1. So negative 16 times negative 1 would be plus 16. So 9 plus 16 would be 25. Now I can't stress this enough. The only reason why we're multiplying just the first term and the last term is because we're using a conjugate. If we were multiplying two complex numbers that aren't conjugates, then you'd have to FOIL completely. But here we don't have to. So here I'm going to multiply in the numerator just the 6 times a 3 and 6 times negative 4i, so it's going to be 18 minus 24i. Break this apart into our two pieces. We get 18 over 25 minus 24i over 25. Neither of those can be reduced, so that is our answer. So that's what you need to know. That's what you need to know with dividing by a complex number. We just need to remember we multiply the numerator and denominator by the conjugate of whatever our complex number is. So with that, good luck with your assignment.